And as well, and I mentioned yesterday, one of the resources that are available, it's I don't know if you have managed to explore the channel, but if you go to YouTube, we've been uploading quite a few videos in the Orca Hub Energy YouTube channel. So please feel free to browse there and follow as well. And to me, it would mean a lot of help if you just share this in your LinkedIn profiles, and more people can actually have a look at the videos and benefit from the material there. There is also a lot of material in our GitHub repo account. In our GitHub account, we are starting to build quite a few repositories. And there you go. That's our GitHub. And in the GitHub at the moment, we have 4 repos, and we're working on 3 libraries: one for reservoir engineering, material balance; one for production system analysis, where we have all the aspects of vertical lift correlations for well, and also in flow performance relationship. And this one is just one that we are starting, which is a decline curve analysis. Just starting to build it, and if you go to that one, you would probably have to dig. There is nothing there, but you will have to dig to the source because it's ACR, because we're building the files as we speak. And also there is quite a few exercises here, DCA, one related to the offshore field in the Norwegian sector of the North Sea, Wolf field, finite elements examples, some foundations, Python foundations, and so on. So I don't know if you have heard about this material, but I plan to keep pushing for more of this in 2021. So you're welcome to join, contribute, check, and learn from those resources. And I also teach Python and some other trainings around Python for companies and individuals, if at some point you might be interested. Right, so let's continue from where we left yesterday. And this is where we are. Which we were in, sorry, in exercise. This is not the exercise. We were in exercise 2. And I'm going to ask a couple of questions here. So obviously, oops, this is not what we saved, what I saved yesterday. This is not complete. Oh, yes, sorry. So yeah, that's fine. That's fine. So one thing, it's to recognize what we have here. We have a couple of variables, and in here we have, as we mentioned yesterday, we have a string which defines a date. But as it is, it's just a date. It is not really sorry, it's just a string. It's not a date in a format that you could use in Python for the time being. Lucas, I think if someone can please paste in the chat the couple of files that we distributed yesterday for Lucas to follow up on today's lesson. But please, thank you. So we have a string here, and what you see here is actually a series of strings in a list. So these square brackets indicates that we have a list of elements. And in fact, if I run these few lines, let's wait for a moment. It's connecting to allocating a resource. Google is allocating a resource. Now I have a resource. So I'm going to run this cell, and this cell. I'm going to add a cell here underneath, or actually better. I'm going to move it just underneath this one. Let me run this cell. And one thing that I can show you is, let's get the number of elements that are in that list. So I can use this a function, which is basically the length of the number of length of elements here. Oh, sharing is locked because of the security. Yes, Roy, if you can do it, that would be great. I think there you go. And so we have 27 elements in that list. And one thing that I can do is explore element by elements. If I go dates, I can check for the element 0. And the element 0, of course, I would expect to have the first index. So Python, for those that have worked with other programming languages, so other programming language are referenced to the index number 1. Python is referenced to index 0. So if you want to access the first element of a list, that would be your element 0, and you would use square brackets. Usually when you use a parenthesis, it's because you are executing a function. It is a function. So in that function, you are giving some variable, and it's executing. That function has certain capabilities defined. In this case, we have the dates, and I can extract any element. So if I want to extract the last element, one thing that I can do is do -1. And as you can see, I have this element. So I can go from 0 to whatever element I have here, which is, I guess, a 27. There are 27 elements, so that will be the 26th element. Or and what would happen if I go 20? If I put 27 here, I would get an error message. And in this case, the error message is indicating that my list is index is out of range. Now, it is very important to notice that and understand, as you start to work with Python, start to read these messages and understand how to debug these messages. Of course, we don't have enough time to do it here, but one important lesson is to have a look at the very end and see what is the error saying. Usually, they are quite they have a lot of previous messages, but they are quite explicit in terms of what is actually failing. So, right. So let's do something interesting here, and we're going to force some errors. One thing that we would like to do is make a plot. For those that have worked with Python, or probably you haven't worked, but have you heard which one is a library, the most common used library in Python for plotting and producing some graphs?
That would be matplotlib.
Yeah, matplotlib will be the library. So if I would like to generate a plot in matplotlib, I would have to import the library. So I would have to go into import matplotlib, right? And usually, that's interesting, you have a recommendation here from Google Colab on what to import. Usually I do this one, which is matplotlib.pyplot, which allows you to produce plots directly within the user interface of Google Colab or JupyterLab. Right, so can someone explain what this ASPLT means?
It's an abbreviation.
It's just an abbreviation, exactly. So I could call this University of Calgary, and later on come here and then call University of Calgary, and then access matplotlib. One thing that I'm trying to access here, and I don't know if you can help me. Usually when I am working in JupyterLab, let's say I have my JupyterLab, and this is quite useful in JupyterLab. I'm going to add an empty lab, an empty file. If I do import matplotlib .pyplot as University of Calgary, let's say I call it like that, and later on I do UOC dot. If I hit tab, I have a list of the functions and variables that I can access on that library. And I don't know if you know how to do it in Google Colab. If you know, let me know, because that's pretty useful. And if you do it like this, in this case, for instance, if I do uoc.plot and I open the parentheses and I hit Shift Tab, I can get a small documentation of a library. So and that's quite useful. And I can also hit just Tab and get again the list of variables that I can put there if I want to use a variable. Now in here, I'm not quite sure how to get the reference, but I know that it's uoc.plot. And what I would like to do here, oh, here we go. I think it's coming automatically. Okay. So what I would like to do here, it's just make a plot of dates and well rate. And I think this is not going to work as well as I'm thinking that it's going to work. Oh, there we go. We've got a plot there. And not so nice. Actually, that UOC, it's just an example. I'm just going to come back and use the most common label, which is a PLT. Yeah, and then use PLT here. And one thing that I can do is I'm going to do scatter plot. And then I have some points. And the other thing that I could do with matplotlib is change the size of a figure. So I'm going to set my figure size here before I produce a figure. I'm going to set it up to something a bit bigger, for big size equals 2, and I'm going to set it to 15 times 10. Let's see how that looks like. Okay, so I have a bigger plot. So very quickly I have gone from producing some plot with the data that I have, and again I have a couple of lists, and one thing that we're going to live with that for the time being, with these values as strings. I'm not going to convert it to dates until we have really hit a limitation. The next thing that I'm going to do, I'm going to put some access to this, some access and some colors to this plot. I can change the color to whatever color I want, really. So I'm going to put black, and hopefully you see the colors of the dots being changed. And we can do some more things like PLT dot. I believe that we can put a PLT dot title, and this is my first plot. See if that works. So here we go. We have this is my first plot, and of course you can do many more things with matplotlib, like changing the size of the axis here, put the title to the axis in the X and Y labels, and many more. You can add a legend to your plot and so on. So the next thing that I'm going to do is give you another way in which you can define these equations. So one thing that we did the other day was pretty much define. Let me see if I can write this. We have Q equal qi times t to the power, and this is where I can use a math function, which is a math dot, I think it's power, and then in power I can put t and minus m, and then this is time the math dot exponential, and let me open a couple of brackets here. I'm going to do in the first one a over 1 minus m times, oh, this is outside, times, hopefully this should be all right, t times, if I get it wrong, I will probably copy it from somewhere else, or I will leave to you to fix it for the next class. So in fact, this is q, that is math dot power of t to 1 minus m. Hopefully that should be okay. And then I can subtract 1. And this is going to give me an error because I don't have qi defined. I don't have any of the other variables defined. And of course, one thing that I can do is set up another cell here and define all those variables. So I'm going to set up my qi to 200, qi, say this is an unconventional well.
Alejandro,
yes.
Is there a reason why you're using math dot power for the like a power instead of like double star?
No, well, there is no particular reason.
Because I think double star would be a lot easier.
Yes, you can use a double star. Let's put it. Let's say I'm going to replace it here. Let's say I'm going to use t double star and t double star m minus m. That would be practically the same. And in fact, if you go to NumPy, that we haven't gone to NumPy, you will see that you can use also NumPy, and I prefer to use NumPy. Usually, you can. Let's do a quick test and see what is quicker, because sometimes when I have these questions, I prefer to do a quick test and check it what is actually quicker. So I'm going to do m. M is 1.16. and a is equal to 1.6, okay? So that is fine, and I don't have a time defined, and ideally I should take the time from these dates, but for the time being, I'm going to define some time in days, and I'm going to set my own list of numbers. In this case, might be recognized as integers: 10, 30, 60, 90, 120. Okay. And well, one thing that you will see is first of all, I am evaluating. I want to calculate immediately with this equation a whole list. I want to apply the whole equation to the whole list. But really, the equation is only able to receive a one value, one float value. So one thing that I can do. So can you tell me what this means when I put the numeral here in front of a statement?
Just comments it out.
It's just a comment. Yeah. So in fact, the one equation cannot start from 0. So you have to start from a very low number. So let's say we want to see if that well has a rate of 1,000 barrels per day with an M of 1.6 in an A of 1.6. At 30 days, how much is that well going to produce? Oops. Let's see if that works. If that gives a crazy value. So there is nothing return here. There are two ways in which you can return a value after you execute the sale. You can simply call that value, or you can call a print.
Alejandro, you also have an extra T in there. Just yeah, maybe.
Oh, yes, sorry, thank you.
Yep.
Yeah. Well, this is obviously this is wrong. There is something wrong because I cannot have an initial rate of 1,000 and then I will have an increasing rate. There is something funny going on in my equation, but I'm not going to worry about that at the moment. Okay. Now that is fine, but what if I want to apply? I don't want to have a time just at T60. I want to run this at all these times. What can you give me some solutions?
I think a for loop for that.
Okay, let's try a for loop. And so the first thing is to try a for loop. And I'm going to copy this. And I'm going to do a lot of things that are not elegant, but I'm just to illustrate the point. Just to illustrate the point. So let's do a for, and I'm going to call this, instead of T, I'm going to call it times. And I'm going to do something interesting in Python, which is for every time in times, which is it's a very quick shorthand to iterate through a list just by setting the value of the name of that list. And usually when I have a list as the one at the beginning, you see I'm using a plural here, and I should be using actually rates. Yeah, well, rates, in fact. So if I want to iterate over that list, I just simply use for time in times. Of course, you can use whatever you want here, really. You can use for, let's say, if I want to use exactly this equation and I want to use for T in times, and then every time I got a new T, it's going to be evaluated in this equation, and it's going to be printed. Yeah, this is a bit annoying. So whenever you are using statements, you need to put your column here. Okay. So if I run that, let's see what happens. For time, times is not defined, and that's interesting. Why is times not defined? I have written times here. Anyone can tell me? So I have this error. It says name times is not defined, but I have times here. What happened?
Because you have to initialize it, I think, or you know?
Yeah, exactly. So for those that that are having a look at this environment for the first time, so if I change this cell, I always need to rerun the cell to make sure that the variables are allocated in memory. So now if I run this, so I have those values, right? And okay, this is one way to do it, and another way to do it, and you will find very useful, is using use of a function. So let's try to define a function. And my function, it's going to be defined with the def statement. And soon you will realize a lot of values of using a function. And this function is going to be called whatever you want to call it. And I'm going to call it University of Calgary _ Duong. And that function I can simply copy this equation and put it in here. But what I really want to do is every time that I go through the function, I want to replace the initial rate. I want to replace A, and I want to replace M, or in this order. In this case, it would be M and A, just to be fastidious and consistent. So when I define a function, I have to, just a second, guys. Just when I define a function, I need to return a value. So in this case, I'm going to return Q. Yeah. So that line is really not doing anything, but it's allocating in memory a function with these variables. And whenever I pass the values, whatever values I want to apply here, it will return a Q. So one way to do the for loop using the function, and in fact, I need to also pass the time. Let's pass the time. One way to do it is go again to a for loop. Yes. And in the for loop, I'm going to, instead of using all this, I'm going to use my function. Yes, that I already defined here. And I'm going to run that function. So this is a bit more elegant. Why do you think that this is important? At the end of the day, I'm just using exactly the same function. I'm just putting it inside or inside of another couple of lines. So it's actually taking me more lines to write the function. So why should I bother on writing the function?
It's easier to make changes to the function when it's not in the main.
Okay.
That, and also you can just call it, like if you have to calculate it in another moment, you can just call that function, so you don't have to write the whole line every time you're gonna use it. You just write U of C duong, and you can call that function.
Right, exactly. So as you have seen here at the top, I actually introduced a mistake. That was to test if you were actually following up. And if I write the equation again and again, I may introduce mistakes every time that I write the equation. So I just write my function so I have some reusability of that function later on, and I make sure that I'm always using the same function. Okay, so that's one thing. And just to finalize, or to make another more interesting example here, and I'm going to start using NumPy. I know it's a bit too quick, but let's use NumPy library. So this is using NumPy. One thing that I like to do, this is too big. And actually, one interesting thing about the way the notebook is structured, if you see here, I believe, you see that it's a kind of creating a documentation as I start to write my notebook. So if I go to, and obviously if it's showing us a new section because I have one numeral here, but I really would like to put this almost as a not as a master section, but as a subsection. Right. So we're using NumPy here, and I always like to go back to the top and import the libraries that I'm using, so everyone understand what I'm using, what sort of libraries I'm using, and you have an idea of what the book is about. It's very difficult to understand what you're doing if you import the libraries in the middle. But if I know that you're using NumPy, if you're importing machine libraries at the top, I know them more or less what sort of algorithms you're using and probably which libraries you're using at the top, at the bottom, which functions. So I'm going to import NumPy as, usually this is a convention, people, and this is a suggestion. Again, you can call it University of Calgary, MP, whatever you want to call it, but this is a convention and people call it MP. And so I'm calling it MP. And I'm going to repeat some of the steps that I have here. For instance, these steps here. But I'm going to do a trick with times. And I'm going to do an np dot, oh, here we go. We have the help here. And there are quite few functions in NumPy. NumPy is a library where you can specify arrays. You can specify two-dimensional matrices or n-dimensional matrices, and you can make operations with the arrays in multiple ways. One thing that it's quite useful, you have a range, and what is the other one that I use a lot? Let's just say range for the time being. So we have a range, and a range will have a start, and a stop. So I can say, for instance, 1 to 365, and then let's see what I have in times, right? And this is what I have. Okay, this is what I have. I have pretty much a bunch of numbers from 1 to 365. And I don't remember what is the other one that you can do. Forgot the other one. It will come in a bit. Sorry?
Lens space, I think.
Yeah, linspace. Yeah, exactly. The linspace is a linear spacing, and I'm going to do actually from 1 to 365 in 10 steps, or let's do 12 steps. Okay. So I have the numbers equally spaced from 1 to 365 in 12 intervals. So you have 12, and if you see this array, has 12 values. So now this is interesting, because if I do type and I do times, this, you see that this is not a list. And if you remember here at the beginning, I have well rates. And if I do, for instance, the type of well rates, it tells me that it's a list, because everything within a square bracket is well rates. Now, but I can actually convert a list to an NumPy array, and that has some advantage and benefits that I'm not going to go through at the moment. But one advantage is with this list, and you can do things like, I want to do well rates plus dates 0. What do you think would happen with that statement?
So I'm guessing it will only produce, like, it will append them as a list, like it will put together both of them. Yeah, not even like.
Yeah. So it's trying to concatenate a value, and it's not letting me concatenate a value. Let's say, it's not letting the concatenate a value because it's not an array, a list. Because date 0, it's just a value. But if I put it in a list, I can actually add a list. But the problem is that what it's actually doing is appending that string at the end. Yeah. So if I want to say well rates plus well rates, and you want to have just a double of that, let's say you want to do that operation. In a list, what would happen is you will append that list to the other. So that is not really what we want to do when we are doing operations between lists. We want to do something different. So I'm going to delete, I'm going to turn back into the types. So you have that as a reference in your types, not type. Okay. Now, what I really want to do is, let's say I have these dates, and one thing that I'm going to do, just for the sake of illustrating NumPy operation, and that's just a comment. I'm going to do a NumPy.array, and I'm going to convert that well rates to a NumPy array. And I'm going to add NumPy array well rates. Oops, well rates. So what happens here? Now I have the first number is 497. So which in fact is a double of this number. So I'm actually able to do that operation. And in fact, I can do some other operations here. I can do one number times the other. So I can do many more operations, and obviously I can divide, and then I have everything is one here. So that is why you should be using NumPy, and it's the library. It's pretty much tuned to do a numerical operation. And actually, one thing that we could do, that trick of producing those numbers from NumPy, I'm going to do another trick here. I don't want to use a for loop. I'm just going to pass directly into this function. Instead of passing times, I'm going to pass, and actually I'm going to pass these times underscore NP, times underscore NP, a NumPy array. And these times I'm going to leave it as a list, just to illustrate my point. And if I pass here times the first list, I would have an issue, as I mentioned before, because I can only use a float number in that equation. But if I pass, hopefully, a NumPy array, oops, what's happening there? Okay, now that's it. That is failing, but that is failing because of another reason, and I will show you in a bit. So that is failing as well. So it seems that I need to put it in another loop. And what I'm going to do here, now using NumPy, I'm going to define another one of these functions, another one of that function. Let me put it just above, and I'm going to call it u of z1 underscore NumPy. And I'm going to convert this to a NumPy, and then you will tell me why I'm using NumPy. So I'm going to use NumPy power of t to the m. Hopefully this will work. Let me see. T to the m, and here I'm going to use NumPy. I think .x should be all right. Yes, .exponential is all right. And here I'm going to replace by NumPy power, right? And I'm going to store this function from here. And again, now it's going to be called uc1np. And hopefully, if I do that, and I get q back, right, here we go. So we have now a function that is compatible with NumPy. I'm not using a for loop, and straight away I'm evaluating all the numbers that I have in a list. Okay, sorry, I've been talking, and there are some comments in the. Run the cell again, I think. Okay, different functions can be combined in the main. Different functions can be combined in the main. You can generate multiple functions. As you can see, I have 2 functions here, and I can use multiple functions and name it whatever I want, really. And I can do something more interesting here, just to make it a bit more. I can put something like term 1 is equal to this, and then another line, I'm going to do term 2 is equal to this, and then I'm going to do q is equal to term 1 times term 2. It's exactly the same, just making it a bit more readable, and I'm going to have exactly the same results that I had when I was running well, I didn't run the functions with those values, with times FP, those values. But we can copy actually these numbers to make it consistent. And let's put those numbers in here. Yeah, magically. And then obviously this is just going to be only the first time. And this is evaluating the loop here. Now, I believe that there is something that I do in Jupyter Lab, which is time it. When you have questions about what is the best way to do things, you can put this percentage time it. And oh, that was a bad idea. That was a bad idea. When you're using time it, make sure that you don't have any print, because time it is it will work a function a lot of times. It will run that function a lot of times, and to test what is the performance of that section of the code. So if I run it now, time it. Where is it? So it runs actually 100,000 loops at 7.93 milliseconds per loop. Okay, that's a base of 3, more or less at this. Okay, let's do the same timing, but now I'm going to do a timing here. That was very interesting. This is a bit slower. The slowest round at 12.6. I'm surprised that this is slower. Probably because of a number of terms I'm specifying here. I'm not quite sure, but I'm very surprised that that was slower. Let me see again. No, still slower. Same amount of loops, bit slower. Well, you learn something every day. There you go. And so whenever you have a question, I think that someone was asking me why I was using math, and I'm not quite sure if it would make any difference, but we can try. So we know that this is 7.93, and it's 100,000 loops. And if I do the same here, and that was minus n, I believe. Let's see. Yeah, actually, this is slower than T2 T star star. Okay, that's interesting as well. So I'm gonna make a copy of both, so you have both codes there, and also remember that you can do some of those little tricks to check your code performance and test, yeah, what is probably the best approach to do certain things. I think finally, let's bring the whole thing back to the together. And what I would like to do is make a plot of the rate of a well, and I'm going to use this correlation and see how can I adjust these coefficients and overlay these couple of plots. So I know here at the top, and let's put a comment here of what we're going to do actually from what I heard yesterday, Control MM, and I'm going to put here a comment which is bringing everything together. And what we're going to do is plot historical data versus this would be a decline curve analysis correlation, or let's call it correlation. Okay, simple plot. I'm making the same figure, so that's should be exactly the same. And I have roughly, I don't know how many years I have here from 0 to this time, but that is part of a task that I'm going to leave you to do, and figure out how you can do an overlay of these two plots. So the idea now on your next task is somehow I have this long equation, which I can do, let's say, I'm going to copy the same equation that I have here. And I want to do, instead of times, I'm going to do, instead of days, I'm going to do the times numpy, and I'm going to return Q. Let me copy this, duplicate this hero selling tab. No. I'm going to duplicate this, so you have a full code there. And this, I'm going to call this QMP. Okay, so I have my times MP, and I have my QMP, and I'm going to put a color blue on this. What I would like to do is this is my correlation plot, and I am going to use a plot instead of a scatter, right? So what I would like you to do for the next session is on this task here at the end, produce a plot with both historical rates and correlation dates, and this is what is called the decline curve analysis. Do one, and I want you to overlay both plots. Okay, and if you have time, the task 2 is adjust manually QI, N, and A, so that the plot is fit, or so that the correlation is fit. Okay, so let's do that. So for the next time, I'm not going to show you the results, just a very quick, let me show you how this should look like. But this should look something like, without putting in my screen the solution. It should look something like this, okay? So I'm gonna copy that, and hopefully I can put it here. Can I? No? There we go. I should have saved this as an exercise 3. Let's call it as a exercise 2B. Save, copy. If I'm gonna do it 2B. So would that be okay for the next session?
I think so, yeah.
So questions, please.
I'm wondering, so to define these values, QI, A, M, and those, like, do we just do them randomly, or should we do like a mesh, like, okay, go from this to this and like just adjust them like a parameter sensibility analysis?
What you can be as creative as you want. I like that idea. What I'm going to tell you is the next step that I'm going to do in the next class is take multiple wells and take multiple data from an external file, because at the moment we're just putting data, copy and pasting data. So I'm going to take an Excel, because that's more or less the common workflow, import the data from the multiple wells, and use a core fitting library to understand what are the fitted values in an automatic way. But for this exercise, just do your test manually to feel the pain, and then for the next one, we'll make it easy.
Great, thanks.
Tereska asked if we have the recordings will be posted. I guess so. Yes, as Wu mentioned, this will be recorded and posted somewhere. Any more questions? Good, good. Well, have a good Sunday, I guess, and rest of a Saturday for you. And I'm going to try. We have a full lockdown here in the UK, but I'm going to try to go to a supermarket to get some groceries, as it's the time where no one is in the supermarket at the moment. So take care, everyone, and I'll see you on Tuesday. Yes.
Thank you, Alejandro. Yeah.
Thank
Okay.
you. See you on Tuesday,
Awesome.
everyone.
Take care.
Yeah.
Bye.